Hi everybody, this is Mr. Foley and Salt and Pepper. We're going to talk about equilibrium of salts. We're going to find the concentration of ions. We're going to find KSP. We're going to find solubility. We're going to learn how to make a precipitate with a common ion effect. This is a lot of math. Get out your calculator right now. You need your good calculator. Good calculator. And let's hop to it. Dissolving equations for salts. So when I put salt in water, we know that it dissolves. Dissolving equations mean that it's going to ionize. Okay? Ionize means to make ions. So CaCl2 is going to split apart into calcium and chloride. Now from the periodic table, calcium is +2 and chloride is -1. So if you remember, periodic table is +1, +2, +3, 0, -3, -2, -1, 0. So that's how I got that. All right. Now I have to balance this so there'd be 2 in there. Okay. Oh, stop doing that. Kf is going to split to K positive. K is in here. Plus F negative. And stop doing that. Come on. F negative and F is around here. Okay. What would be the KSP for them? Now notice K is really, it doesn't matter that this is SP. It's still going to be K. It's going to be products over reactants. So the K for the first one, I'll call this number 1, is calcium +2 in brackets times chloride -1 squared. Squared because I have this 2 here. And then this is a solid, so it's not there, so I'm going to leave that off. Number 2, K would be simply K positive times F negative. And again, no powers because I don't have any coefficients. Magnesium hydroxide is barely soluble in water. 5.97 times 10 to the -24th moles dissolved per 1 liter of solution. What is the OH negative at equilibrium? What is the KSP? Okay, so I'm going to write magnesium hydroxide's dissolving equation. Magnesium hydroxide is MgOH taken twice. Mg is +2, hydroxide is -1. When this dissolves, it's going to make Mg +2 plus 2 hydroxides. Now what I'm going to do is I have what's called an ice diagram. An initial, a change, and an equilibrium amount. Okay? So it's barely soluble in water, and this much dissolves per 1 liter of solution. Now remember, this is a solid, and these, because they're ions, are aqueous. Okay? So I'm going to start off with a solid, and I don't really care how much of the solid I have. I have some of the solid. Because it's solid, it doesn't matter exactly how much, and before any of it dissolves, I have nothing and nothing. The change is -x. Now I want you to know this. -x, come on, come back here. -x is molar solubility. That means how many moles will dissolve in 1 liter. Okay, so notice this says 5.97 tenths to the -24 moles dissolved per 1 liter. This is going to be x. That's going to be -x. This is going to be +x. This is going to be plus. Why did I put 2 there? No, that's not going to work the way I want it to. This is going to be plus. This is going to be +x, and this is going to be plus. This is going to be +x, and this is going to be +2x. 2 because of my coefficient. So I'll get twice as many hydroxides as magnesium. So in the end, I write literally, I don't care. And then I have x, and then I have 2x. Now, because I see that this is the molar solubility, and I wrote down that -x equals molar solubility, I can then figure out what these concentrations will be. So if x is molar solubility, then x equals 5.97 e -24 molar equals Mg +2. And then 2x equals, double that, 5.97, oops, put a 0, 5.97 exponent -24 times 2, which is 1.194 e -23 molar equals OH negative. Okay? Now, that answers my hydroxide question. Now, what is the KSP? Well, remember, every K is the same. Come back here. Every K is the same, so K equals, come on, K, I don't know why it's doing this. K equals mg, K equals mg plus 2 in brackets times OH negative squared. That's K. Now my mg plus 2 is 5.97 E negative 24. And my hydroxide is double that, which was 1.194 E negative 23 squared. And when I do that, times 5.97 exponent negative 24, and I get an itty bitty number of 8.51 E negative 70. And that's my K. Okay? Sorry, the screen's losing that stuff. I hope you got it when it was there. What is the molar solubility? So remember we learned that molar solubility is minus X, and it gives me the KSP. Okay, oops, I don't want a laser pointer. I want 10. So I'm going to write the dissolving equation for this first, Ag2CrO4. And when it dissolves, it's going to form 2 silver positives plus 1 chromate negative 2. So just like before, I'm going to do an ice diagram. I, C, E, initial, starting, change, and ending at equilibrium. I'm going to start with sum because they didn't give me an amount, so I'm going to say sum. Before any of it dissolves, I have 0 and 0. The change is going to be minus X plus 2X, so this is a product, that's why this is positive and the other one was negative, and then plus X. I'm sorry, those lines are there. I doubt if I'll be able to erase them, but I'll give it a shot. Oh, but it did erase. And then in the end, I have I don't care, 2X, and then X. Now I do have the KSP expression here, so I'm going to write K equals silver squared times chromate. And then I'm going to substitute in what I can. KSP is 1 E negative 12. Ag positive is 2X quantity squared, and chromate is X. Come on. And chromate is X. So that means that 4X cubed equals 1 E negative 12. Okay? So X is going to equal 1 exponent negative 12, 1 exponent negative 12 divided by 4, enter, and I'm going to take the cube root of that. To take the cube root of something, so I have X cubed equals 2.5 E negative 13. X is going to be, the way I like to do a cube root is 2.5 E negative 13 raised to the quantity 1/3. Okay? I don't know what a cube root button is. I know there is one, but I don't really care. 1 divided by 3. And that's how you get a cube root. If I get a 4th root, I'd raise it to the 1/4 power. And X is 6.30 E negative 5. Oh well, X is 6.30 E negative 5. And remember, X equals molar solubility. So my units would be molarity. Okay? All right. Now, we talked before in the first podcast about Ks. Okay? So, with our Ks, Q and K. So, what we want to figure out for precipitate forms is I'm going to write my Q expression. So, I'm using the same one as before. Right? I have silver and chromate. So, from before, I have Ag positive squared times chromate. Ag positive is 2E negative 3. Still have to square it. And chromate is 1.55 E negative 2. So ask my calculator, 2 exponent negative 3 squared times 1.55 exponent negative 2. And I have 6.2 is Q. Now I need to compare that to K. So 1, excuse me, come on, go back. 1E, okay. 1E negative 12 equals K. So what's bigger? Well, E negative 8 is bigger than K. If Q is bigger than K, then you have too many products, so reactants that precipitate will form. If Q is greater than K, then you get a precipitate. Hey, that's it. Review, be able to do an ice diagram. Minus X is molar solubility. Coefficients are important. Common ions, oops, I'm sorry, I meant to get rid of that. Common ions reduce the ability to dissolve. And we are done. Toodaloo-loodlees.